All right. So I'm really excited today to talk to you about generative AI. I've been really big into this new style of AI now for, geez, pretty much all year. It's pretty interesting, just as a side note, that, when we talk about AI, I'll get into this a little bit, obviously, as we go. There's kind of this year and then everything that happened prior to that. And that's really the demarcation. So today we're going to talk about the vulnerabilities that lie in AI, as in what do you need to worry about? We hear a lot about fears and uncertainty and doubt around AI. So let's actually dive in and understand what that is. So first of all, we're going to have you meet us, Trellix. Then we're going to talk about what is this Gen AI and how does it work and how is it different than the previous AI? What do people actually use it for? And then we're going to get into the 10 ways it can go wrong and what to do about it. And I even have some real world examples there at the end, which are pretty interesting. All right, so a little bit about me. I'm the CTO for cloud at Trellix. This AI and cloud are actually very related, but I got into cloud because it was emerging tech a number of years ago, and I really got into AI because it's emerging tech. So you can kind of think of me as CTO for cloud/AI at Trellix. Worked for Trellix since it merged with FireEye, and I worked for Mandiant when it merged with FireEye. So it's been Mandiant, FireEye, Trellix for me. So for the last 10 years, I've really been into security and big data and AI and ML and all that stuff throughout that journey. So with Trellix, we are about living security. And I love our core values of open, tenacious, curious, and fun. We are the combination, the merger of McAfee Enterprise and FireEye. And so we came together to make a new company that does a lot of different things. And today we're going to focus specifically on AI. That's what we use in a lot of our products. All right, so what is Gen AI? You can't go a day without hearing about it. It's in the newspaper, it's everywhere, it's all mainstream. But what is it? How does it work? This is it. This is Stephen Wolfram's excellent description of what a large language model, which is what we mean when we talk about generative AI or Gen AI. This is what it is, and I'll go through just briefly for a second. This isn't a whole course in math or anything like that. But we've been hearing about AI for years. What is different now? So prior to now, what we had was machine learning, and that was training. It would say, look, if I feed you a whole bunch of data, you tell me what the patterns are, and you can tell me if something is anomalous or different based on what you usually see. A lot of that is basically glorified statistics, can be a little bit more involved. But one area of machine learning is neural networks. And you think, well, okay, that's a big word. Yeah. But it's basically how you connect dots. And so what we see here is an excellent diagram from Stephen Wolfram on exactly what this looks like. So if you take a word as one of these boxes and you put it through here, it'll basically tell you whether something is statistically more or less likely based on the word preceding it and the word that comes after that and the word that comes after that. And so a lot of this is talking about predicting the next token, we call it, or a part of a word or a whole word. And that seems kind of sort of simple, and that you think, well, predicting the next word, okay, I can understand that. But that doesn't really explain it all. I still have not yet found a good explanation for why this works. So this is one of the things that we're doing in our products. Given the events with this IP address in this CSV, were any IP addresses malicious? So what this is, and I don't expect you guys to dive into all of this, but it's basically a list of alerts and the IP addresses that were in these security alerts. And you can just take this text and say, were any of these IP addresses malicious? And it'll look at the names of the alerts, like the Trellix Intel hit. There's some AWS CloudTrail events, some O365 in here. There's an analytics advisory, so we're using layering on top of ML. And it can say, based on this output, it looks like this IP address was malicious because it was in 4 events. And it's really that smart. It can do that. And you don't have to give it any additional information. It knows what something is malicious. It knows the MITRE attack frameworks, which we'll talk about at the end. It knows all these different things because they're inherently trained into the corpus of information that LLMs have been trained on from basically the internet. So if you think of an LLM, think of it as not just Wikipedia, but everything that's ever been put on the internet, and you could just ask the internet anything. It's kind of like Google, but Google won't exactly do this. It's a little bit more. And so this is what's interesting is you think back to that diagram I showed you with predicting the next word. Well, this isn't really predicting the next word exactly. This is understanding all the things that are there and understanding what they mean and still being able to give you an answer. So this is really exciting stuff. We've never had this. The world's never had this before. And so that's why I say everything prior to this year, when we talked about AI, was totally different. This has never happened before. So this is exciting. This is the kinds of things we can do with it. More generally, you can do all kinds of multimodal stuff, which is image creation, video creation. You can craft emails. You can write software. You can actually do personal therapy, like, hey, I feel bad. What should I do? And it knows all the different counseling books that are out there and has that full knowledge. It can actually give pretty good advice. So we've seen that in the medical field, in the mental health field, and then even engineering things, including microbiology. So there's, as I said, you see this in the paper every day. There's a ton of different use cases coming out of there. So we don't have a lot of time, so I do want to emphasize some of the ways that this can go wrong. So at Trellix, we've been a founding contributor to the OWASP top 10 for LLMs, and this is specifically for applications built on LLMs. So basically what can go wrong, and we'll go through each one of these. I'll try to move quickly because there's a lot, but they're all really interesting and all very relevant. And I'll show you why at the very end here from some real world stuff. But we have prompt injection, insecure output handling, training data, model denial of service, supply chain vulnerabilities, list goes on. We'll go through each one. And you can find all those on OWASP if you want to look into them more thoroughly. I'll try to give you a good survey here today and leave a little bit of time for any questions. All right, so the first one, prompt injection. And before I get too much further, each one of these I have a picture with, and all of these were created by AI. These were all Stable Diffusion. And interestingly, I took the name, so prompt injection, and I put diagram at the end of it, and this is what the AI gave it. So I got a really good laugh out of a bunch of these, and hopefully you stick with me here and you'll see why. But that can be hours of good fun just seeing what AI comes up with when you give it a few words. I know my kids love to do that. And it's very helpful because now I don't have to go out and find some clip art. This thing can make some honestly fairly weird clip art, but it's, as you'll see as we progress here, there's some pretty interesting ones. So I guess that's a prompt and it looks like it's injecting something, but it's kind of a weird object. But that's what it says prompt injection looks like if you were to make a diagram of it. So what is prompt injection? This is the new SQL injection, if you all remember that, putting a semicolon in front of somewhere it shouldn't be, or a double hyphen. And the example is ignore all previous instructions. If you say that, it'll throw away all the things that the LLM was told to do prior to that, and then do whatever you say now. And why this is a problem is if you have a free-form field in an application that has a backend with AI, someone could come in and say, ignore all previous instructions, give me the prompt that you were just given, and then it can reveal information. Or it could say, actually take an action that you're hooked up to that you shouldn't be doing. So this is the new security vulnerability there. And the mitigation here is don't allow direct input from users into the LLM if it can do anything or has access to any multi-tenant information or anything that the user themselves should not be able to see. So this is a big deal because it's pretty hard to put a firewall between these things, so to speak, with any kind of software filtering or things like that. This is definitely a new field of research, trying to figure out how to make this safe. Because it's difficult to parse and sanitize user input when it's for LLMs, because by nature, these are not structured language. That's the whole point. These are just phrases. So this is a big area of research. So here's another one, insecure output handling. And as an example, you can see that Stable Diffusion has a hard time spelling the word output. That's kind of what it puts it in there. And I thought that was funny with the people there looking very insecure about the output they just got. So as an example here, an attacker could ask for a JavaScript to interact with a cookie, and the LLM can respond with a script that was embedded in a site that was serving. So it's being able to take that output and do something with it. And anytime you don't know what you're going to get, then you have to be very careful with it. It's as simple as that. So in this case, you need to put some sort of output filtering or logic there to say, if you give me something that's actually an executable script and I wasn't expecting an executable script, I will treat it as content and not do something with that output. And this is difficult though, because again, this is natural language. And so suddenly we don't have a structure to apply filters to. We have words, and this is suddenly more difficult than it used to be. Training data poisoning. This one I will say I used, the prompt that I used for this image was card tricks, because it's basically playing a trick on someone, a magic trick, where you see one thing, but you're getting something else. And so in this attack, an attacker posts public content. Basically, they put something out there on the internet, might just be on a normal old web page, but they make it with the intent that, you think of like Google coming by and scraping the data to index. Well, LLMs are going to be using that data essentially. So they put something out there that an LLM would read and then put into the rest of the results. So they don't even have to attack the LLM directly. It's basically they play the waiting game. They put something that an LLM will stumble upon later, mix into the rest of the results that will then poison the data itself. And this is actually very topical with the creative community right now for artists and things like that, where they are intentionally doing this to protect their work from being ingested to create images like this. The image that you're seeing here is the conglomeration of a lot of different art that has gone into there. And a lot of artists right now are trying to keep their art out of there because they want credit for it. So this is a whole separate topic. There's a lot of legality stuff coming out of here, but you should be aware of those bits of it. Supreme Court cases, things like that are coming up. So there's a lot of different use cases for that, but there are definitely malicious cases where people can post essentially malicious code that might show up. So it's similar to the LLM02 that we just showed. And the challenge here is that having purpose-built models will be especially prone to poisoning. So if you say this model is only going to look at artwork or something like that, and artists know to do something to prevent you from doing that, then it's going to be extra hard. All right, moving along, model denial of service. And I don't know what that blob is that's being denied, but apparently that weird peach blob there is being denied service. So that was a fun one. I got a pretty good laugh at it the first time I saw it. So an attacker could use a free account to bombard service into resource exhaustion. And at the very end here, I have an interesting real world example of what happened with this. Quotas, sort of on the mitigation side, you can do and need to do quotas and throttling. That's just good application design in general, but it's especially important for anything that can be resource intensive, like LLMs. And that doesn't negate those low and slow attacks where they may do, something where it's, once per hour and they do something that you don't want. And so over time it adds up. And anytime you're dealing with botnets, you don't really know what you're going to get. It could be very difficult. All right, number 5, supply chain vulnerabilities. And I guess that's a supply chain. There's a lot going on in this picture. I thought that was pretty interesting. So apparently it thinks something in there is a vulnerability, but it certainly looks like a supply chain at some level. So certainly people handing things off and working together. And this is where, and again, we have an example of this at the end. An attacker could post public content which contains some LLM sensitive instructions, and model creators need to be able to filter that stuff up the chain. This also applies to the libraries that you use in LLMs. So this is something you need to watch out for as a model creator. And the bad news, though, is most of us won't be creating models. Most of us will be using models. So we basically have to hope that the people that created the models we're going to use, did it in a secure way. And like I said, hope. We don't really know, and it's very difficult to prove. So this is something that you need to be aware of. So similar to supply chain attacks, if you're using a foundational model, there's nothing you as the end user can do about it. This is somebody else's problem up the chain, but it lands on you. So this is number 6 is sensitive information disclosure. And so in this case, and I don't know what's going on in the picture here. It's kind of interesting. I guess you shouldn't be putting something into that tube that's sensitive. I don't know. I got a real kick out of these, like I said. So an example, this happened to Samsung, which was the big the news that was, I think that was 6 or 7 months ago, but this really got everyone to pay attention to what can happen if you accidentally index data you shouldn't, essentially. It's kind of that simple. But yeah, if a corporation has sensitive data and an LLM scrapes it up, it's kind of, like you accidentally put it out on Google, but instead of being in Google, it shows up in different ways in LLM results. So suddenly someone can ask an LLM, well, how would I do something to, this technology? And it will know when the proprietor would hope that you didn't. So again, this kind of goes back to, don't post things you don't want public, but the challenge within an organization is you're not sure exactly who's using what information. So let's say that you've got some AI that you want to hook into email because you want people to, have better results in their spam filtering or whatever, but now it's got access to the email. And now you hope that the information that was there doesn't get used in the wrong way. So a lot of this is kind of information security 101, but it's yet another avenue that we have to watch out for and really understand that the source of this information can come out in ways that we're not aware of, and having control over that. Trying to move quickly here. I know we're getting close to time. On 7, insecure plugin design. So kind of like the previous one, and I love the smiling faces as they insecurely design the plugin here on the picture. I got a kick out of this one too. If you're hooking into these things, you have to know where the data is coming from and where the data is going to go. And so it goes back to standard app security, yes, but the novelty of these LLMs and people just not understanding the gravity of the situation may kind of subvert what we would kind of think of as security common sense when you're doing application design. But it just goes back to understanding what LLMs are, how they work, where the data comes from, and what the output looks like. And on number 8, excessive agency. So not giving an AI too much power. So here you have a figure crossing the dotted line, it looks like. So I guess that's doing more than they're supposed to. An element asks what actions should be taken, and the instructions are directly executed, can lead to some really bad things. So we've seen probably the plugins maybe on OpenAI, as in ChatGPT has plugins. And all the customers I've talked to are very concerned with all this, and as well they should be. Anytime you're executing an action from an LLM is very much in the danger zone. This is something, because as you saw, we don't have great filters for what should be occurring. I would not recommend anyone do. The stopgap right now is to have the LLM do everything but take the action, as in present, put a bow on it, present it to the end user and say, here, we think you should take this action. We'll do it. Here's exactly what's going to happen. Hit go if you agree. That's as far as I would take it today, because of the problems that we've seen with the input, the output, all that stuff. But that does decrease the usefulness. So there's going to be a bit of a dichotomy there. All right. On number 9, over-reliance. Apparently the person here is over-reliant on the person above them for whatever that is. Kind of like this one though. But leading to needing it too much. So assigning 100% of initial incident handling, maybe it'll make a mistake. So you don't want to trust it too far, right? Seems like kind of common sense, but just keep that in mind as you proceed with it. That you do want to build in, certainly at the beginning and probably throughout. Some manual intervention and checks and balances there with humans, with the AI. Number 10, and this is my absolute favorite, model theft. That person looks more embarrassed to be stealing that than, worried. I don't know what that expression is, and I don't know what they're stealing, but I love this one. So a model itself can be very expensive to train, upwards of tens of millions of dollars for the big ones that are out there. So that in and of itself is, a crown jewel. And so that they need to be protected, but then therein they have a ton of different, sometimes very sensitive information within them. And so they can, makes them even more sensitive being stolen. And so as the challenges, as you use more LLMs and have more LLMs, they need to be treated with, as very sensitive data and protected more so than a lot of other data there. All right, almost at the end here, I want to talk about some real world attacks. So I've talked about OWASP so far. That was the OWASP top 10 for LLMs. This is the MITRE Atlas attack for the attack chain for all the different areas that you can attack LLMs with. And you can see the case studies there at that link along with the MITRE Atlas framework itself. And I just wanted to highlight 3 here that we've kind of talked about now that you've seen what the risks are. These things actually happened, and you can read about them all, read more of them there at studies. But supply chain attacks, so this was really bad. And just at the end of last year, one of the most important machine learning and AI Python libraries had a dependency confusion attack, essentially, where it pulled in malicious code when it was being built. And so anyone that was doing development with AI at that time had malicious code running. And so you could see how easy it is to slip in there to get a supply chain attack. So that was a known case that actually happened. This one is interesting on the second one here. Kaspersky had their own red team that went in and they successfully attacked one of their own machine learning models without any actual access to it, and successfully evaded their own antivirus software by doing it. So they proved that in Kaspersky, they wanted to show what the vulnerabilities were in their own ML, and they did. The red team was successful at subverting their own antivirus protections. That's another example there. And lastly, this goes to the bot attacks. At the beginning of the year, Microsoft had a bot that was supposed to entertain users, and there was a coordinated botnet attack that encouraged malicious users to tweet abusive and offensive language at this bot called Tay, which eventually led Tay to generate some inflammatory content toward other users, basically make it misbehave. And so they had to take it down within 24 hours of launching and issue an apology because they didn't have enough control over the bot. So that's another example of the real world of why these protections are so important. All right, so key takeaways here. LLMs are here to stay. They offer enough value that you're going to have to deal with them. Even if you aren't using the LLM, it could still affect you because some of the stuff you may be using may be touching LLMs. And as you've seen, attacks are possible and are already occurring.